A topic as big as open channel flow needs to begin somewhere. On that note, let's begin with a river. Looking at it from plan view, a river looks like a squiggly line. I assume that all of you have seen a river before, but have you ever wondered what determines the flow rate in the open channel? I admit that it is not the most natural question to ask if you are communing with nature, but if you're going to learn how to be an engineer, it is a valid question. For example, if we make the slope of the channel steeper, then does that increase, decrease, or have no effect on the flow rate in the channel? A steeper channel means that the velocity should increase when compared with a channel with a shallow slope. In other words, velocity is a function of the slope of the channel. You might also be able to imagine that the roughness of the channel would affect the flow in the channel. Boulders, tall grasses, trees, these should create a slower channel velocity than a channel that is lined completely with concrete. So we can also say that the velocity is a function of roughness. If we look at it at the section view of the channel, you might be able to guess the next parameter. If the flow rate stays the same, but we make the channel larger, will this affect the velocity of flow in the channel? Compare this to the opposite condition where we keep the flow constant but we shrink the channel section so that the water is deeper and more compact. When water is spread out on a wider cross-section area, it interacts more with the channel roughness and will flow more slowly. Therefore, the cross-sectional area must be considered. However, this is not the only shape consideration because the length along the channel cross-section that is in contact with the channel is also important. The cross-sectional length we call the wetted perimeter, and it essentially measures how much of the river's channel bottom is interacting with the flowing water. Because area is in feet squared and wetted perimeter is in feet, then many of the early mathematicians combined these two terms to create the hydraulic radius, which is just the A divided by the P. The hydraulic radius is not referring to a circle of any sort. It is merely the fact that the result of the calculation has units of feet and, well, what would you have called it? To complete our function relationships, we can say that the velocity is also a function of the hydraulic radius of a channel. Open channel flow is any flow that is not pressurized or that flows solely under the influence of gravity. Therefore, flow in a pipeline can also be considered an open channel if there is a free surface of water within the pipeline itself. Similar to the trapezoid channel shown above, the velocity of the flow is a function of the roughness, slope, and the hydraulic radius of the channel, just as before. This approach even applies to natural channels where their shape is simply classified as irregular. Regardless of the shape of the channel, we can analyze the velocity of the flow in that channel as a function of the slope, roughness, and shape of the channel.